This is CGTN, China Global Television Network.
The myth of Icarus shows how long we've been obsessed with flight. The first hot air balloon was the Sky Lantern, developed in China during the Three Kingdoms era, 1800 years ago. In 1493, Leonardo da Vinci drew plans for a helicopter, almost 450 years before any would fly. The first manned hot air balloon flew in 1783, piloted by the French Montgolfier brothers. Two more brothers, this time American, piloted the first heavier-than-air craft. Their flyer flew 120 feet on December the 17th, 1903. And despite the fact that we can now do this, and this, and this, that dream of Icarus, the dream of individual flight, still haunts us.
But today, I'm going to meet a man that has managed to do that, fly by himself. He straps 1,000 horsepower to his back and reaches speeds of 85 miles per hour. Richard!
Pleased to meet you. Yes, come in.
Oh, wow.
Yeah, this is a little bit of a museum to the various prototypes we've gone through in the last 3-4 years. So.
Incredible.
It ended up being a little bit of an evolutionary journey, and actually started, dug this out, this horrible lump here. This was the very first prototype arm assembly.
That seems really heavy.
Yes, it's got lots of sharp corners, and it was built in a hurry just to, yes, you can feel how heavy it is.
Oh my goodness.
Its weight reflects the uncertainty I had right at the beginning of just how sensible it was to have a jet engine attached to your arm. So I thought, well, let's just build it out of something really solid, so in case there's some kind of problem I haven't thought of, it's not going to hurt me. The conventional wisdom was that with a spindle spinning at 120,000 RPM, you would actually find that you couldn't move it. So like a spinning bicycle wheel, if you tried to move it, it would fight you in a perpendicular fashion. Turns out not at all. It was easy, really benign. It was just a gentle but increasable shove of the air coming out the other end.
So that sounds like lesson number one.
Massively. And then rapidly went to the point, and they're stuck up on the wall up here. They are now heavily modified, and ignore the one with the plastic tube in it, but those are originally just aluminium tubes with lots of holes drilled in them to make them lighter, and a series of structures there to start playing with the geometry of where exactly on your arm should you put one or more engines. We had no idea about this. I had a theory that if you put one either side of your fist, that the net result of the thrust would feel like it was going up your arm, and it kind of worked out. But we played around a lot with the geometry. I mean, that's all patented now, but there's a lot of cleverness to the geometry of the precise arrangement and layout of the engines to give you a sensation of the thrust in a way that minimizes the load on you. So it now is just like you're leaning forward on a table. It's like very, very effortless. There's something we should point out as well. I've talked about the arm engines, but actually a large part of the support comes from the rear engine, which originally was an engine on the back of each leg. You know, we've got the original boots up in the corner there, which I used to use to house the engines, but they gradually moved up the legs until they were kind of on my posterior, and then eventually got consolidated into one larger engine here. And that provides a third of the lift to lift, a third of your body weight and the weight of the fuel and itself. So between those 3 points of the kind of camera tripod, that gives you the support to be able to actually manipulate and control and maneuver.
But you've gone through a lot of mistakes and failures.
You can see from some of the examples, we've had a few spills over the last 4 years.
Oh my gosh, that's really mashed up.
Yeah, I mean, but it's quite deliberately soft aluminium, so it looks more dramatic than it is. But yeah, you have to take some degree of risk when you're breaking new ground and doing something new. That learning journey was all about actually trying things that had never been done before, but all the time managing the downside, because actually, to be honest, it involved falling over mostly on a farmyard where we were testing it. All the time, only from a couple of feet though. We always absolutely manage that downside risk. Otherwise, if you can't get back up again because you've broken your legs because you've gone too high, you can't keep innovating and trialing.
So much of the control is actually coming from your body.
Entirely, yeah, absolutely all of it. All you've been augmented with is the propulsive force to manipulate. In a not very exciting way, it's a bit like a bicycle in that it brings some technology to the human mind and body. Without a human, a bicycle doesn't even stand up by itself. But look what it can achieve with a human balancing on top of it.
Oh, I love that analogy. And this is your lab?
Yep, this is where we build, test, break things, rebuild things. Yep, absolutely.
I guess one of the key features that you're concerned about is how much it weighs.
Yeah, so anything that flies there has to be a consideration of the weight that you're trying to lift. Especially in our case, we don't have wings with this version. We are only flying by literally throwing enough mass of air downwards fast enough to lift you off the ground. Actually, an important point, a lot of people think this is pushing on the ground. You know, the Newtonian physics doesn't work like that. This is simply blowing air downwards and you rising up. It doesn't make any difference whether you're 2 foot off the ground or 20 feet or 100 feet.
So it's a bit like pointing a hairdryer at the floor.
Yeah, just a very powerful hairdryer, or probably even a domestic garden hose. When you turn it on, you can feel it shove you very slightly. It's that same force. There's mass being thrown that way, so naturally it wants to impart the same force the other way.
To understand this, we need to remember 2 things. 1, gravity is the weakest force in the universe. The reason we stay attached to the Earth is simply because it's so big. 2, Isaac Newton's third law of motion states that for every action, there's an equal and opposite reaction. So the action or the force exerted by the engines on Richard's body is enough to overcome the action or force of gravity, holding his body to the ground.
Because we're flying, blowing just air downwards and we're not using wings, yes, weight is a critical thing. So, using aluminium, using this polymer, trying to minimize the structure and size, not having enormous big complex heavy control systems, all that kind of stuff really helps. And as I mentioned, the lighter and fitter you are, the easier it is, the less power you need to get off the ground.
And getting off the ground here means a lot of our old friend, the 3D printer.
This is a 3D model of the arm mount of the jet suit. So all of the parts of the suit are 3D modeled first, and then some of them we make kind of manually, but most of the jet suit is fully 3D printed now. So we 3D print it out of polymer, which is nylon. That's a piece like this. So this is the standard method we use, where you build up the parts layer by layer in powdered plastic, and each layer is kind of welded to the last one with a laser. So we do a lot in polymer, and then other parts are metal parts like this one that we use for the arm mount. So on this arm mount, there's aluminium sections here which are printed, and the arm tube is now polymer, and that is it's gone through a load of stages of iteration to get to the point where we've now got plastic parts instead of metal parts, because it keeps it lighter and cheaper to make as well.
It seems like you've pretty much got the whole mount there. The only thing that's missing is the engines.
Yeah, so this is just the arm mount geometry, so the engines will be clamped inside both of those. This section around here, if we can rotate round, you can see the fins around here which help wick away some of the heat from around the engine nozzle. But yeah, this is the geometry that allows us to attach that propulsion to your body. And the whole point of the jet suit is to allow a human to fly with the least equipment possible. So as close to just a human flying as we possibly can.
So can you literally hit print on this piece of software and it goes to the printer?
Yes, well, so the metal printers are like £500,000 printers, so we get that printed somewhere nearby here. On smaller parts that we iterate really quickly, like pieces like this, these can be printed in the lab on printers like the one we've got behind you. And what this will do is allow us to print something very, very quickly, attach it to the suit and test it almost immediately. We can then bin this thing, create a new one, and implement all of those new design learnings very quickly into the final design and get it printed properly again. So this allows us to quickly learn and iterate.
How has it felt to be part of designing something that is so pioneering?
It's really cool. Like, it's amazing to be able to look down and see pieces that you actually designed kind of mounted on your body, and you're actually flying with it. And also, I absolutely love kind of high power systems, so anything that makes loud noises, produces useful propulsion and spits fire, that's pretty cool.
But where does that fire come from?
We've got one large engine here on the back, and we've got 4 smaller ones, 2 on each arm, okay? So you can sort of see the pilot would be facing that way, the pilot's head would be here.
Yep.
Now, I've got actually, this is a 3D printed model of one of the engines. This is the one, you know, the rear one in the back, the bigger one. Fundamentally, it's not dissimilar to the engine you'd have on a jet fighter or a civil airliner. You have an intake and a compressor, which compresses the air going into the engine. This is slightly different from a conventional large gas turbine in that the compressor is centrifugal. So it spins the air around the outside and then feeds it into the combustion chamber. The kind of engine you'd have on a 747 actually is a normal linear compressor which takes the air straight down in one go. There's a bunch of kind of boring reasons why you have to go for a centrifugal one to get it small, but otherwise that's the main difference.
Linear compressors need to stack multiple pairs of rotating and stationary blades in what are known as stages. A single stage generally doesn't provide enough compression for applications like aircraft engines, so they're stacked in order to achieve higher pressures. Centrifugal compressors are harder to stack in multiple stages, but there's often enough total pressure generated by a single stage to be effective for smaller engines. They're also easier to design and ideal for 3D printing. So the manufacturing and size advantage outweighs the lower total pressure disadvantage.
So once the air's in the combustion chamber at high pressure, the fuel is injected in there. It's jet fuel or diesel or kerosene or paraffin, and that then burns, creates an expanded amount of hot air, which then escapes through the back. But the fun thing is, and you can see the blades in there, I mean they're all printed, but you can see the little blades. They then catch in that airflow, and the rotation of that turbine wheel is what drives the compressor. So it kind of feeds itself, if that makes sense, obviously with the net input of the fuel. And simply, you should really think about what comes out of here as like a fire hose of water. You know, it's like an actual fireman's hose in terms of what it feels like, but instead of water traveling, I don't know, at 80 miles an hour, it's air traveling at 1,000 miles an hour, which it needs to because it's so light. And that's really it. So something that big will weigh about 5 kilos and put out about 55 kilos of thrust.
So how much does something like this actually weigh?
So the whole thing's about 27 kilos, and you can feel one of the arm assemblies here, that's about 6 kilos. It's not too bad, but it's about 350 horsepower, so it's pretty powerful compared to its weight.
So that's like a sports car in my hands right now.
Pretty much, yes, indeed.
But I mean, you know, that's really heavy. But does it feel like that when the engines are turned on?
No, because they're more than lifting their own weight. So even though that weighs about 6 kilos, the whole assembly there is pushing with 44 kilos of push. So it more than removes its own weight.
And how safe is it to actually have something like this strapped to your back?
Yeah, I mean, we can go through what the risk items are. I mean, the fuel, you can see it in the bladders here. The fuel, as I mentioned, is jet fuel, typically, which sounds all terrifying, but actually it's pretty much the same product as diesel. So the reason it's used in the airline industry is it's very energy dense, but actually pretty safe. It's nothing approaching gasoline in terms of its propensity to burn or ignite or explode. It's very benign. So, you know, in 4 years, we've never had any kind of issue with the fuel from a fire or you know, a flammable point of view. So as long as you keep it contained correctly, you know, and don't put any source of ignition near it, it's really not a problem. Nearly all of the rest of the risk is simply down to how high you fly it once you can fly it off the tether. So for our training clients, we have them tethered the whole time, and we have a remote shutdown system that if at any point they're not comfortable, and we've barely ever used this, but you can just shut down the system. So actually, despite the noise it produces and the perception that it's going to be a dangerous thing, actually it's really not if you know what you're doing.
Enough theory, time for some action.
Okay, let's go fire it up. So you'll be able to see as they accelerate and the combustion kicks off.
Life moves pretty fast. Ideas move at the speed of sound. Technology moves at the speed of light. If you don't filter out the noise, you might miss the details. We pay attention to the details because they matter, showing you a different perspective. See the difference.
every story starts out like this.
Okay. We'll head up now.
But beyond the rush of the numbers, there's always a more fundamental question. What happened? Who has been affected? When market-moving decisions are made, who's responsible and why?
Let's get some reaction on ground. Joining us in Johannesburg is Shini Somara. Hello, Nairobi.
This is how all stories begin. See how they end. Only on Global Business.
How will your world change today? What happens here? What happens there? Or what you make happen for yourself? If it matters to you, it matters to us too. Your stories are the stories that need to be told. Africa Live. Find your voice.
Hello, I'm Stephen Cole at CGTN's European headquarters in London.
My international guests help me help you set your agenda.
A well-looked-after body will make the brain happy.
That is the evidence.
We want to share the benefits of China development.
This story is far from finished.
Join me on the agenda at these times every week.
Just been given these because apparently it's going to get really loud, and now Richard is going to get his jet suit on. It's really exciting. And are these regular clothes?
It's pretty much. I mean, these are cotton trousers. Sometimes I wear biker jeans. This is a leather bike jacket as well. I mean, the rule is you just don't want to wear anything that's synthetic because, you know, anything that's synthetic can kind of melt.
How are you feeling at this stage? Have you done it so many times that it's kind of like second nature?
I have no concerns about my ability to fly. I always have a healthy respect for the fallibility of the technology, so that, you know, there's always a chance that you have a technical issue, which worst case could see you fall out of the sky, so that's why you don't go too high. So it's always a respect for that. Yeah, I suppose it's a sense of wanting to just execute what I need to do, which is the little flight demonstration.
Now, you've literally just strapped a jet suit on in like minutes.
Yeah, it's even quicker to take it off, yeah.
Is that
you can
it?
do it yourself, but I'm being lazy with my team member.
And that's
where's
it?
my helmet gone? That's one thing I need. Okay, let's go fire it up. You should try it. So you'll be able to see as they accelerate and the combustion kicks off.
you feeling?
Yeah, it's great. Yeah, no, really good. I mean, it's a very simple little flight, but yeah, you see the control and stability.
Yeah, I mean, you were just so stable.
Yeah, it's as effortless as riding a bike in terms of how you control and coordinate it.
I must say, you can smell the jet engine fuel. I can feel the heat coming off the exhaust. Yeah. But you honestly look like you were just floating on air.
That's what it feels like. You just feel like you can go anywhere you like in three-dimensional space.
I want to try it.
Right, well, let's give you a go.
I must say I'm pretty nervous about having this jet suit strapped to me because I have no experience and everything seems quite dangerous, but I really want to feel what it's like to fly because I think it's just an exceptional experience, and Richard made it look so easy, and so let's see how I go.
Right, you put that on, it's just simply over your shoulders, so just don't worry for a moment. Put that on. For this first go, what we do is we dial the power down so it's super low. There's a trigger in your right hand that I'll go through all this again when we're up there, but as you squeeze that trigger, you'll just feel the power come in, and you'll get very quickly to the point where there's no more travel in the trigger. That maximum travel in the trigger will be preset to be very low. Okay. So you'll be able to just sort of work out that if you point them both here, you shuffle backwards. If you point one to the side, you go to the side, etc. The idea of the first go is just to sort of familiarise yourself with the very basics of what happens when you point the engines around. So it's nowhere near going to be the same power I just used.
I'm sorry, the idea that jet engines are allowing you to hover in the air. I get the mechanics, I get the theory. It all stacks up from an engineering point of view, but to actually be able to hover in the air like that, I'm going to have to do it to believe it.
This way? Yeah, one side and one the other. Yeah, you can slacken a bit if you need to. Yeah. Does that feel pretty good?
Yeah.
So as a little test, if you want to shut it down at any point, we can do it ourselves, but you can also shut it down. If you tap that button, if you feel there's a little rocker switch, you can play with it. If you click up and down, it's 2 fingers. So up and then down. Feel it, so it rocks up and down. You know, it's frankly more controlled than a kid learning to ride a bike. If you walk down here, I'm just going to hold your arm a bit. This is probably the most dangerous part of the whole thing. It's walking down the ramp. Okay.
Oh, it's heavy.
Yeah, you get lighter when it starts up. So what we're going to do, you're going to press that kill switch in, the lights will be flashing, okay? I'm going to watch all the lights. When I say, okay, good to go, I want you to lift these up and move them down into this position.
I could feel the downward forces ramping up on my arms, and the smell of jet fuel was overwhelming. At this point, I'm glad I'm attached to a harness. So clearly I need a bit more practice, but for my first attempt, it really hit home how hard it is to gain control over the engines, and they were at their lowest setting. Actual liftoff was probably going to take a few more attempts and a lot more courage.
He did it for you. Get the weight up here, yeah? How was that?
That was
crazy, huh?
awesome. I'm shaking like a leaf. I don't know if that's exhilaration or just terror. There's all these thoughts going through your mind, like, am I absolutely nuts to be doing this?
That's very common, yeah.
Plus, you know, when I think about the fuel and I think about the power that I've got attached to me, and it's kind of humbling because you realise that you're not.
They don't look like they do much, do they? They're little metal tins, and yet the amount of kind of power and
the
noise.
The force, and like the knowledge that a slight movement could send you spinning.
Yeah.
And that was low power.
Yeah, that was as low as it goes.
Gosh.
But you say that about slight movement will send you spinning. You're achieving a much greater balance feat by actually standing on 2 feet. The stability you have with those thrust vectors is giving you an enhancement to what you normally have. It's really highlighting how really good we are at balance and how quickly, with a few more goes, you can pick that up. And there's a moment where your brain just gets it. It just recalibrates to feeling where that force is.
As well as being able to defy gravity, Richard is also the holder of 2 Guinness World Records.
Part of the reason we reset our own Guinness World Record back in November, I think it was, we improved it from 32 miles an hour to 85 miles an hour, and that was because we were using this leg wing with a series of little strakes and aerodynamic improvements on the legs, which helped lift my body flatter, which meant that particularly the rear engine was actually pushing pretty much entirely horizontally, which is why I just felt this great acceleration and started to fly more like a plane than a kind of hovering jet suit.
So in the same way that a Harrier jet would kind of tilt its engines, are you able to do that manually?
Yeah, we've got complete autonomy over 2 legs of the triangle, 2 legs of the camera tripod, because we can move our arms wherever we like. So, you take off by gradually lowering them and getting yourself lighter and lighter until you come up, and then you can land or go down again by flaring out a little bit. You can point those entirely backwards if you want. Now, if you do that, you need something else to be keeping you in the air. Well, if that's a wing, then great, you've got tons of horsepower to push yourself forward. So a Harrier's 4 nozzles, they used to swivel from vertical to almost completely backwards. So we've actually got way more control than the Harrier aircraft.
You've developed something that allows you to be superhuman. You're a superhero. What kind of technology has come out of all of this work that will affect the way we fly?
Yeah, I mean, it's not unhelpful that and it's sort of accidental that a lot of people seeing us fly, their immediate go-to reference is a sort of Marvel superhero. I mean, that's kind of flattering and really quite fun. There isn't much like this that humans have done before. In terms of practicality now, this would not be my chosen way to take the kids to school or pop down to the shop for a pint of milk. But then again, the first motor cars were considered noisy, smelly, inefficient and terrible compared to the best technology at the time, which was a horse, perfectly good horse. And look where cars have got to. I'm not going to lose too much sleep over worrying whether we do revolutionise human transport, but I do think we have created something that stirs people's minds, makes them re-question, re-challenge how we travel and how we become mobile. Since humans have evolved, we've been used to this force of gravity holding us to the ground. We've looked up at the birds and always thought that would be really fun. We've made amazing progress in the last 150 years of getting in flight vehicles and flying around inside them. Well, this is just opening people's minds to, if we go back to basics, what do we have to add to our human form in order to actually fly a bit like we always imagined?
So dark matter can travel through anything, but to increase the chances of finding it, the answer lies deep underground in something created from outer space.
Travelling down 2 kilometres underground, the concept right now is a little bit unsettling. It just seems to be getting darker and darker.